जो है वो लीड कर रहा है।
वो
तो वो
तो समझ
किस
में
किस।
आ गया था, बट वो डायग्राम ड्रॉ कैसे करते हैं वो समझ में।
अच्छा अच्छा अच्छा, आप जैसे मान लीजिए कि हमें पता है कि रेजिस्टेंस के केस में जो है वो क्या होता है, सेम होता है, दोनों सेम फेज में होते हैं, है नहीं।
हाँ।
तो अगर हमें इसका ड्रॉ करना है तो क्या हो गया, जैसे ये मान लीजिए ये है आपका आपका करंट है, तो वोल्टेज भी जो होगा वो क्या होगा, ऐसा ही होगा, है नहीं।
हाँ।
यानी और जो वोल्टेज नहीं, मान लीजिए या आपका मान लीजिए ओवरऑल वोल्टेज जो आपने ट्रांसफार्मर से सप्लाई किया है, ट्रांसफार्मर से सप्लाई किया है, और जो आपका रेजिस्टेंस में जो जा रहा है वोल्टेज, दोनों सेम फेज में होगा,
हम्म।
या करंट भी मान लीजिए। उसी तरीके से आपका ये जो है आपके केस में जैसे ये
कैपेसिटेंस
करंट
में
है।
करंट लीड करता है।
हम्म। तो करंट जो है वो लीड करता है, यानी लीड कर रहा है, यानी ये जो होगा, ये कैपेसिटेंस होगा, और ये इंडक्टर, ये उल्टा हो गया क्या, ये इंडक्टर होता है और ये कैपेसिटेंस होता है। ओके, ये हम लोग देखेंगे, यानी ये जो करंट जो है, ये आप देखिए ये लैग कर रहा है, ये लैग कर रहा है 90 डिग्री से। लेकिन
हम्म।
कैपेसिटर के केस में देखिए करंट जो है वो लीड कर रहा है 90 डिग्री से।
ओके। हम्म।
ज़्यादा है ना, ये 90 डिग्री से ज़्यादा है, मतलब इसको
हाँ।
अगर हम 90 डिग्री बढ़ा दें तो ये ऐसा है। तो
बस।
ये होता है इसका केस। ये हम लोग देखेंगे जब हम लोग एसी पढ़ेंगे तो देखेंगे इसको।
बस।
बहुत इजी
थैंक यू।
है समझना। नेक्स्ट नेक्स्ट क्लास में हम लोग 6th चैप्टर शुरू करेंगे। अल्लाह हाफिज, अल्लाह हाफिज।
कैसे अल्लाह हाफिज। थैंक यू।
हेलो सुफियान, अस्सलाम वालेकुम। हेलो सुफियान, कैन यू हियर?
Yes.
Okay, let us wait for. Good evening, Rishita. Yeah, how are you guys?
Good job, what about you?
I'm good. I'm good. Yeah. So let's wait 3 minutes more and then we'll start. Which one? So we were doing this question, right? We'll continue with this question. Yeah, let us wait for 2 minutes more. Okay, so yeah, let us continue what we were doing. Right, let me just start this question from the beginning. And today we'll complete this chapter and then we'll start the third one. So yeah, let us quickly finish this thing. Yeah, so the question was that what is the capacitance of not the parallel one, but something like this one, right? So we know that this distance is fixed. So capacitance is simply A epsilon naught by D. But now in here, this D is changing. This is a variable. So for this case, we took this small element dx, right, at x distance. And now because we have two varying distance, one is this y and the other one is this x. This one is fixed. This y naught is fixed, right? And the area of this plate is a square. But if we take this stripe, which is dx, and it has an area, this is a and this is dx. So this will have an area a dx, right? That we understood. So we calculated the small capacitance dc, which was area, small area, and epsilon naught by this variable distance. And what is that? That is y, right? And this total y was how much? So this is a dx, and this y was this fixed distance plus this varying distance y1. And we also knew that there is a relation between because this integral is dx, so we want the integral in the form of x only, right? That has to be the function. So we wanted to integrate this thing. So C is integration of epsilon naught a dx divided by y naught plus y1. And how did we calculate y1? So we had this triangle. This was y1. This theta is always fixed. This is fixed and this is x. So tan theta was perpendicular by base. So y1 was x tan theta. And also we know that this is a fixed quantity. So there is this fixed distance. And there is this distance was how much? So this was a. Right, so this distance was a, and this was how much? Let's say this was also a, I guess. What was this distance? Hmm. This was not a. What was this distance? Okay, so yeah, let's keep it as x tan theta, right? So then this y1 was x tan theta, and this has to be some fixed distance, right? Mm, this distance. Let's say that this distance is some b, right? So then what do we have? We have this integral epsilon naught a dx, and then y naught plus this x tan theta, right? So this is the integral, and then we can write it as, let's say this whole distance is b, and this we know is a, right? So this tan theta would be again how much b by a. So this is epsilon naught a dx and y naught plus this distance is x and b by a. So we can take, I guess this was also y naught. I don't remember. I guess this is also y naught. Okay, let's take it as y naught. So this is y naught. If this is some other distance, then we can also put whatever distance is that. So this y naught we can take common. And this is 1 plus x by dx. Okay, now what we can do is that we have to take this a also, right? We take the LCM. So this becomes epsilon naught a dx and y naught by a is outside, and then this is a plus x. And then this is 0 to a dx. Right, so this is the whole integral that we are getting. Is it clear, guys?
Yes, sir.
Now, what do we have? So we can take, all these are constant. So we can take it outside. Epsilon naught, this a and this a becomes a square. And then divided by y naught. And then this is the integral that we are integrating. Right. So now we know that this is a plus x. So we can take it as t. Put a plus x equals to t. So now we have to change dx. So what would be dx? Dx would be dt. And now we can change this integral. So what is this integral? So this is a square by y naught. And then this is dt. Dx is dt. A plus x, we have put it to t. What would be the limit? Can you guys tell me? What would be the limit?
0 to a.
0 to a. So if you put x equals to, yes,
0 to a plus x.
0 to a plus x, right? So x is going from 0 to a. So if x is 0, right, t is a, right? And if x is a, t is a plus a to a. So that is the limit, right, guys? So this limit would be a to 2a. Clear?
Yes, sir.
So this integral, we simply know that this is y naught and this is log of t. And then we have to put the limit to a. So then we can put uh, epsilon naught a square y naught. And then this is log 2a minus log a. So what is this thing? This is log 2a by a. And then we have this is log 2. So this is your answer. So this is the capacitance of that kind of capacitor. Is it clear? If you guys have any question, please tell me. Otherwise, please note down this thing.
So it's clear.
Yeah, please note it down, guys. I have some, I don't remember this distance, right? Yeah, I guess it was y node not only. Yeah, yeah, so this bigger distance, this is y naught only. Oh, who is joined? If it would have been some other distance, then you can just put that distance in place of tan theta, and then it will be, yeah, somewhat different answer. But yeah, let's assume that that's also y. Yeah, whenever you guys want me to scroll down, please tell.
Okay.
Yeah, whenever you guys want me to scroll down, please tell. The limit thing is clear, right, guys? Why it became a to 2a, right? Because it's just adding.
Done.
Done. What about you, Rishita?
Done, sir.
Done. The whole part you guys have noted.
What should
Oh, okay. Okay, then let us start the next question, right?
not done?
So yes.
Not done. Like just
Oh, not
ask.
done. Oh, okay, okay. Yeah, yeah. Sorry, sorry. Yeah, please note down this part.
You're done.
Done. What about you, Rishita?
Done, sir.
Very good. So the next question is, oh, what happened to this thing? Yeah. So the next question is, you have a capacitor, right? And in between the capacitor, what you do is that you have this wall, and then you put some simple pendulum. And this is positive, this is negative. So you put some simple pendulum, and then you have to find out what would be. So you have to find out that what would be the time period of oscillation. So let's say if this setup is not there, you have only this pendulum, and then uh, you are moving this pendulum, right? So in that case, what is the time period of oscillation?
1 by 2 pi root L by G.
Yeah, 1 by 2 pi?
2 pi.
2 pi root L by G. Yeah, yeah, this one, right?
Yes.
So you know that which thing is fixed. So 2 pi is a constant. This length is also constant, and it has only experiencing this mg. Right, this net force is mg only. So this g is also fixed. But if you have some other system, right, something like this one. So in this one, the net force is changed, right? The net force is changed because due to this capacitor, it is experiencing some force, and force is how much? Because this capacitor has some electric field, right? It has this electric field. So due to electric field, this pendulum, let's say it has some charge, right? This mass has some charge also. Otherwise, it will if it doesn't have any charge, then it will not experience some force, right? So let's say it has some charge Q and mass M. So it will experience the force in this direction, the electrostatic force, that is QE, and it will have the mg, the gravitational force. So you have a net force in this direction, right? And how much is that F net? This F net is simply the vector calculation, right? So you have this two vectors, they are perpendicular, right? You know that the resultant of vector is what? So the resultant is a square b square 2ab cos theta. But in this case, the angle between them is 90, so this part is gone. So you have simply a square plus b square, right? So similarly, F net would be how much? This would be F electric square plus F gravity, right? So this is mg square, or and this is QE square. So this would be how much? This is m square g square plus q square e square. Now you see that this F net by second law of Newton, right? What does this Newton's second law say? What
F
does
equals
this
to M.
Newton's F equals to ma, right? So all the forces, that gives you m. So this is equal to ma. So we can write this thing as ma, and then we can take out m outside. So uh, this would be g square, and then QE by m whole square, right? So m and m cancel, and you can calculate acceleration. This is g square plus QE by m whole square. And this is your g effective, right? Because of this thing, the effective gravity is changing. So now you can put this thing in here, and then you will get your time period of oscillation, which is 2 pi root, because L is always fixed. Length of this string is always fixed, right? And this is G effective. So this is 2 pi root L divided by G square plus QE by M whole square half. So this is your time period of oscillation for this new kind of thing. Okay, so please note down this question.
So done.
Done. What about you, Rishita?
Done, sir.
Done. Okay, so now let us solve some questions about the combination of capacitors, right? So you guys already know that if you have a series combination, right? If you have a series combination, then in that case, you have effective capacitance equivalent, which is this one, right? And if you have a parallel combination, then this becomes what? So this becomes, and so on, right? So parallel combination is every positive, all the positive connected to positive, and all the negative connected to negative. You take all the positive terminals and then connect them together, right? So this is your parallel combination, this is your series combination, right? So all the positive ones, no, and then negative, so they are connected alternating, right? So you take the negative terminal, connect with positive, again take negative, connect with positive, so alternatingly they are connected. Now what do we have? If we have different layers of media, right? So then what is the effective capacitance, or what is the effective what is the effective dielectric constant? So that is the question that you have, right? So let's say that you have these two plates, right? So let me just, yeah, so you have these two plates, and then it is connected to positive, and this one is connected to negative terminal, right? Now what do you do is that you put a dielectric medium in this way. You put the dielectric medium in this. So one is this one, and the other one is something like this one. And this one has dielectric constant K1, this one has K2. Right, so this is positive, right? So this will have negative, and this will be positive. Right. So a negative terminal is connected to positive terminal. So what kind of connection is this one? What kind of connection is this one?
What did you say?
I'm asking that you see that this negative, if let's say separate this two thing into uh, two capacitors, right? So this one, the purple one, right?
Parallel.
This, yeah, so they are in parallel. You see that negative one is connected to positive. In parallel, do you see
Yes.
negative connected to positive? No, right? So negative is connected to positive in the series one. So these are series connection, right? This one is a series combination, and the area of all these things is same, right? So area of this plate is same. This one has area A, this plate has area A, this plate has area A. The separation was D, right? So now what would be this separation? D by 2, right? This separation is D by 2. So let's say that we have an overall capacitance, C effective. This would be how much? Because this is a series combination. So this would be C1, C2 divided by C1 plus C2, right? Series combination.
Yes, sir.
And there is only two capacitors. So I will just use the short formula, right? So now I can say that C equivalent would be some A, area is same, epsilon naught, and K equivalent divided by D. Clear?
Yes.
That is the capacitance, right? And C1 would be how much? Let's think about C1. So C1 would be A epsilon naught, and this is K1, right? Divided by D by 2, right? Because that is the separation. So this is C1, this is C2. C2 would be how much? This would be A epsilon naught and K2, and separation is changed D by 2. So I can write it as 2 AE epsilon naught K1 by D. This is 2 AE epsilon naught K2 by D. Right. So this thing, if I write, what would be this thing? So this is 2 AE epsilon naught K1 by D, 2 AE epsilon naught K2 by D, divided by 2 AE epsilon naught K1 by D plus 2 AE epsilon naught K2 by D. So we see that this 2 AE epsilon naught in here, it is common. So this is 2 AE epsilon naught by D. Let's take one thing. And this is 2 AE epsilon naught by D, K1 and K2. We take this 2 AE epsilon naught D by D common, and this is K1 plus K2. So this thing is cancelled totally, right? And then what do we have? So we have AE epsilon naught by D K equivalent, and this is 2 AE epsilon naught by D K1 K2 divided by K1 plus K2. So again, this AE epsilon naught by D cancelled, and you will have K equivalent as K1 K2 2 divided by K1 plus K2. So this is for what? Series combination. Right. So something like this one. That between the plates, right, area-wise, you are filling up different dielectric constant. So I will see the another case also, right? But just note down this part. Is it clear, guys? Is this one clear?
Yes.
Okay, please note this one.
done.
Done.
Yes.
What about you, Rishita?
1 second, sir.
No. Yeah, noted, Rishita.
Done, sir.
Yeah. Oh, yeah. You have two questions which has been asked in JEE, right? One is similar to this one, but it has three dielectrics, right? So one is, so whenever you see area-wise is connected, area-wise is they are attached. Then you have series combination. When you have distance-wise, right? Then it will have a different thing. So let's say this one. So this is another capacitor, not another capacitor, but this dielectric one, and then you have another dielectric, and then you have another dielectric. Right, so this is D, this is 2D, and this is 3D, right? And then it has the dielectric, which is what this is K, this is 3K, and this is 5K. So these are the dielectric constant. Right, so you have C1, C2, C3, and then they have asked what is the equivalent capacitance, right? So you know that this is a series combination. So in series combination, this would be the equivalent capacitance, right? In the previous case, we had only two, so I just multiplied and then took the reciprocal. But now you have three combination, right? So C1 would be how much? What would be C1? Can you guys tell me? Separation is D, this is dielectric constant. So what would be C1?
KAE, KA epsilon by D.
Yeah, KAE epsilon naught by D, right? Similarly, C2 would be 3K A epsilon naught by 2D, and C3 would be 5K A E epsilon naught and how much? 3D. So you see that area remains same in this kind of. So whenever area remains the same, then you have this kind of combination, right? So you have series combination. So you solve this thing, what you will get? This is D, and then K A E epsilon naught, and then this is 2D by 3 K E epsilon naught, and then 3D by 5 K A E epsilon naught, right? So you take D by K A E epsilon naught common. So this is 1 plus 2 by 3 plus 3 by 5. So how much is this thing? 5 threes are 15, right? So this is 15. And then this is 15 plus 3 fives are, so 10. And then 5 threes are 9. So how much is this thing? So 9, 24 plus 10, 34. So you have 34 by 50. And then this is 1 by C equivalent. So C equivalent would be reciprocal of this thing. So 15 and by 34 E epsilon naught K by D. That is the equivalent capacitance, right? So please note down this question, and then we'll understand about the other type.
So done.
Done. Yes, Rishita, what about you?
Done, sir.
No, good. So let us, yeah, let us understand the next question. So I will ask you this question, and let me see if you guys have understood or not. So if I have, let's say this was the capacitor that I put. Now let's say I have this way I am putting the capacitor, and I am arranging the capacitors like this, the dielectrics like this. So what kind of connection is this one? What kind of connection are this one?
Series.
Series, right? Because whenever the area, because the area remains, area of these plates remains the same. So area is same, then it is a series combination, right? This is plus, this is minus, this is plus, this is minus. So alternate connection. So this is a series combination. Now what I do is that, let's say, you see that what is happening with the dielectric constant or dielectric. What is happening? In here, epsilon is changing, epsilon is changing, epsilon is changing, right? Dielectric constants are changing, right? So now what I do is that I have this capacitor, right? And this, I will just draw a line. So this is how it is varying, right? It is varying. So this epsilon is varying. And let's say I take a very small distance dx, right? So what would be the overall capacitance? Overall capacitance would be, it is a series combination. So this would be dx and divided by AA. Is this clear, guys?
Yes, sir.
Because now my separation is dx, and this permittivity is changing as A. So this is varying. And now if I want to calculate, this would be DC, right? So if I want to calculate the overall C, so I have to integrate this thing. So this would be integration of this thing, right? In one JEE problem, they have given this permittivity variation, right? So this is varying like some function, let's say f1x with this x between 0 to d by 2, right? And then the function is changing with x, which is d by 2 to d, right? So then you can do what? What would be the integral then, guys? So this would be simply, I will not solve this. This would be 0 to d, and you have dx, and this is some a f1x, and then this would be d by 2 to d, right? And let me write the first thing first. So this would be simply 0 to d dx divided by AE, right? But this E is changing function into two different say, distance intervals, right? So this I will have to write from 0 to d by 2, and then dx by A function 1, and then d by 2 to d, and then dx function 2. Right, is this part clear? So this is one question. I will not do this. You guys do this question. So function, yeah, they have given the form of the function. What is the form of the function? But whatever form they give, we can solve this thing, right? So quickly note this thing, and then we'll understand about the parallel one. Is this part clear, guys?
Yes, sir.
Yeah. Instead of these discrete numbers, you have a continuous function. This is a function, continuous function. In here, we had 1, 2, 3, we can count. In here, it is not countable, it is varying like some function. So that is the idea of this part. Yeah, whenever you guys have noted, please tell. So I should write it as this epsilon, which is function of x. Yeah, whenever you guys have noted, please tell.
Noted.
Noted. Yeah, what about you, Rishta?
Yes, sir.
Okay, so now let's see another connection, which is like this. So you have these two capacitors. Wait, you have these two capacitors, and then you are adding them like this. So let's say this one. Then this one. Positive, and this is negative. So you see that this negative is connected with the negative of the other. This positive is connected with the positive of the other. So this is something like this. Positive connected with positive, negative connected with negative. So what kind of connection is this one?
No series.
Positive, positive connected, parallel, right? So this is parallel. Now you see that it is not area-wise connected. Area is this whole thing. This is the whole plate. The area is this A. Now you are only in half area. In half area, you are putting this dielectric. In half area, you are putting this. So area-wise, you are not uh, putting all these dielectric, right? You are putting it distance-wise. So now distance is same, right? Now this separation is same. So distance-wise, you are putting. So whenever you are putting it in this way, so they are in parallel connection. Okay, so you have let's say this is K1, this is K2. So C equivalent is C1 plus C2. Now this would be how much? This would be A E epsilon naught and K equivalent divided by D. And C1 is how much? C1 is what would be C1? Sufyan and Rishita. What would be C1? This part is C1, right? So what would be? Yes?
K1 A epsilon naught by 2D.
2D. Yes, so you are trying to say in this one, right? Yes. Are you agreeing with Sufyan's answer, Rishita?
Sir, is 2 up or down?
This is what Sufyan has said, right, Sufyan? Yes. Do you agree with this answer, Rishita?
I think so, sir.
You think so? Please be, yeah, please be confident in your answer. So you see that area is A by 2, right? Distance is D. Dielectric is K1. So this would be, yeah, so ultimately this would be A epsilon naught by 2D. In the earlier case, the distance was different, right? In the earlier case, you see that distance was half, area was same. Area of these plates were same. So this was d by 2. So distance was half. Area was same. In this case, area is half, right? Because you have only this much part of the plate, right? This is something like this one. So you are only putting this part, this area, right? So this is half area. This is the total area, so this is half area of the plate, right? Okay. So yeah, is it clear now, Rishita?
Yes, sir.
Is K and then 2D. Right, so now so let's solve this thing. So this would be K1 A epsilon naught by 2D, and then this is K2 A epsilon naught by 2D. So we take A epsilon naught common. This is K1 plus by 2. So this part cancels, and K equivalent is K1 plus K2 by 2. So in series combination, right? In parallel combination, K equivalent is K1, K2, K3, right? Something divided by n. So this is series combination, and parallel combination. It's different, right? So yeah. So in parallel combination, this is K1 plus K2, something like that, and then in series combination, you have 1 by K, and then something like that. Yeah, so this is the series combination. Okay, so please note it down, and then yeah, this chapter is over. So maybe we'll do some question two or two questions in the next class, but yeah, this chapter is over. Please note it down, guys. Is this part clear? How it becomes series and how it becomes parallel? If it is not clear, you just draw these polarities. You just draw these polarities and then you check whether all the positive ones are connected to the positive ones. So you can have these kind of connections as well. Something like this one. So this part and then this part, this part. So this kind of connection. So this is K1, K2, and K3. Right. This, yeah, just treat this thing as your homework and you tell me that what would be the connection. So you have a mixed combination, series and parallel, right? So this part, this whole and 2, 3 whole, this is parallel, but 2 and 3, they are in series. So that kind of connection. So first you solve the series one, K2 and K3, and then you solve the parallel one. In the next class, I will ask about this thing, right? Whenever you guys have noted, please tell. Yeah, noted, guys.
Yes, sir.
Yes.
What about you, Sophia? Not okay. So yeah, I'll